Okay, welcome back, Math 9s. Here we're looking at section 2.2, powers of 10 and the zero exponent. Okay, so our focus here is to explore powers of 10 and also the exponent 0. Okay, in the first table here, we'll look at powers of 2. So if we have base of 2 and exponent 3, our power to the power of 3, if we write that as repeated multiplication. This is a little review from section 2.1, and then in standard form we can say, hey, that number 2 times 2 times 2 is 8. We continue on here, look at 2 to the power of 2. And again, reminder that this dot in between the two numbers just represents multiplication. The next one would be 2 to the power of 1. Okay, so what we're noticing here is that each time we go down this table, we're just dividing by 2 each time. We're just dividing by our base, right? Our base is 2. I'll highlight that just because we are. Just to identify that that's the 2 that I'm talking about here. So if we go from each line, we are just going to divide by 2. Okay, so if we keep going down and we do an exponent of 0, we get our power. We write that as 2 to the power of 0. And then as repeated multiplication, we would just that would just be, hey, what's 2 divided by 2? That would just be 1. Okay, and we'll just take a little break here. Okay, so let's go down a little bit, and what's the pattern that we see here? If we keep dividing by 2 on each line, we're going to end up getting smaller and smaller. And what we find is that 2 to the power of 0, this is a big idea from this chapter, anything to the power of 0 is going to have a value of 1. So if we write that as our first exponent law, that's any base raised to the exponent 0 will equal 1. Okay, so that's like saying, hey, anything, I'm just putting in x as a variable or not known, anything raised to the power of 0, any base raised to the power of 0 will give you 1. Okay, so if we just apply that, so that makes it really easy for a lot of questions. So for instance, in these three, if we have 4 to the power of 0, well, that's just going to be 1. Here we have negative 4 to the power of 0. So remember, 4 is our base, so we're going to end up with this thing here is equaling 1, and then we have that negative out front of it. Here, the base is the entire thing of negative 4, so negative 4 raised to the power of 0, that's going to give us a positive 1. Okay, we'll work lots more with those positives and negatives when we come back to class. Okay, so backside. So the whole goal of this chapter is to look at both the 0 exponent and powers of 10. So now we'll look at powers of 10. Powers of 10, it's really handy to write powers of 10 because if we write 10 to the power of 9, that's just, well, it is 1 billion, but it's just this number 1 with, hey, it has 9 zeros. And then if we get on this list, 100 million has 8 zeros, well, we write that as 10 to the power of 8. And you get the idea here, 10 to the power of any exponent, well, that exponent will tell us how many zeros follow the digit 1. So 10 to the power of 1, we just looked at this on the front page, but anything to the anything to the exponent of 0 has a value of 1. Okay, so our application for this is we can use the place value chart and powers of 10 to write any number. So if we're looking at this number 3552, well, that's going to be 3,000. If we add to that the hundreds, there are 4 hundreds, add to that the tens, which is 50, and then add to that the ones column, which is 2. So what that looks like is we can say, okay, well, that's 3 times 1,000 plus 4 times 100 plus 5 times 10 plus 2 times 1. And if you write that using powers of 10, that's going to be 3 times, hey, 1,000 is just 10 cubed, plus 4 times 10 squared, plus 5 times 10 to the 1, plus 2 times 10 to the 0. So you see we normally write that in orders of decreasing exponents. So here we have 10 to the 3, then 10 to the 2. Right, so it's just another, and then 10 to the 1, sorry, and 10 to the 0. It's another way to write numbers using powers of 10. Okay, so in these two examples here, we could say, hey, that's going to be 6 times 100, which is 6 times 10 squared. Okay, that's all we're looking at for that one. For this one, we'd have 5,000 plus 7 hundredths, or 5 times 1,000 written as 10 cubed, plus 7 times 10 squared. Okay. Okay, so this section's big idea. There are two of them. Anything with the exponent of 0 is equal to 1. And the other big idea is that powers of 10 give you that many zeros. Give you that many zeros. An example is just say 10 to the power of 3 gives you 1,000, which has 3 zeros. Okay, let's give that a try. Page 61, 6 to 13. That'll give us some good starting point for that section. Okay, I'll see you back in class. Bye for now.